Imagine looking up at the night sky. You see the moon, the familiar constellations, maybe a planet or two twinkling back at you. But tonight, something is different. There's a new star, one you've never seen before. Night after night, it grows brighter and bigger. It's not just another star, it's a visitor to our solar system, a rogue wanderer from the depths of the galaxy. This star isn't just passing by from a safe distance, it's getting closer, and its immense gravity is starting to pull on everything around it, including our home, planet Earth. What would happen if this cosmic guest got a little too close for comfort? Our planet could be in for the ride of its life. This scenario sounds like something straight out of a science fiction movie, doesn't it? A giant fiery ball of gas hurtling through space, threatening to throw our world into chaos. The very ground beneath our feet feels solid and stable, and the sun rises and sets with comforting regularity. We take for granted that our orbit is a perfect, predictable path, but the universe is a dynamic, ever-changing place. The idea of a star messing with our cosmic neighborhood is a bit scary, but it's also incredibly fascinating. It makes us think about our place in the cosmos and the powerful forces that govern everything, from the smallest atom to the largest galaxy. The gravitational pull of this intruder would be immense, a force so powerful it could literally reshape our solar system. Earth is held in a delicate gravitational dance with our sun. It's a balance that has allowed life to flourish for billions of years. But a massive object like another star could disrupt this dance completely. It would be like a bowling ball rolling through a set of carefully arranged marbles. The orbits of all the planets, from Mercury to Neptune, could be twisted, warped, and thrown into disarray. Our peaceful cosmic home would suddenly become a place of celestial uncertainty and thrilling danger. A fun fact to consider: our sun is just one of over 200 billion stars in our Milky Way galaxy. That's a lot of neighbors, and while most of them keep their distance, the galaxy is a busy place. As we explore this incredible what-if scenario, we'll see how such an event could happen, what the consequences might be for our planet, and how scientists are keeping a watchful eye on the sky. So let's put on our thinking caps and get ready to explore the wild, wonderful, and sometimes frightening possibilities of our universe. It's a cosmic adventure that shows us just how special our little blue planet really is. Our galaxy, the Milky Way, isn't a static, frozen picture. It's a swirling, spinning city of stars, and everything in it is constantly on the move. Think of it like a giant cosmic dance floor. Our sun and all its planets are waltzing around the center of the galaxy, a journey that takes about 230 million years to complete one full lap. While we're moving, so are all the other stars. They have their own paths, their own speeds, and their own directions. Most of the time, these stellar dancers are very far apart, with vast, empty spaces between them. It's like everyone has plenty of room on the dance floor. The distances between stars are truly mind-boggling. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. That means it would take light, the fastest thing in the universe, more than 4 years to travel from there to here. This immense distance is our greatest protection. Because space is so big, the chances of another star getting close enough to cause trouble are incredibly small. It's not impossible, but it is extremely rare. For a star to affect Earth's orbit, it would have to pass through a region of space called the Oort cloud, a giant icy shell that surrounds our solar system far beyond the orbit of Neptune. So, how could a star get that close? It's all about the random nature of their orbits. While most stars follow a relatively stable path, sometimes their journeys can intersect. A star could be sent on a different trajectory after a close encounter with another, more massive object, like a giant star or even a black hole. This could nudge it onto a path that brings it right through our cosmic backyard. This isn't something that happens every day or even every million years. These close, stellar flybys are once-in-a-galactic age events, making them a subject of great scientific curiosity rather than immediate concern. It's important to remember that everything in the universe is governed by gravity. Gravity is the force that keeps our feet on the ground, the moon orbiting the Earth, and the Earth orbiting the sun. It's also the force that dictates the paths of stars as they journey through the galaxy. The more massive an object is, the stronger its gravitational pull. A passing star, being incredibly massive, would exert a powerful gravitational tug on our entire solar system. This is why even a near miss on a cosmic scale could have dramatic and far-reaching consequences for our planetary family. Let's imagine that a rogue star has entered our solar system. What happens next? The star's powerful gravity would start to play a cosmic game of billiards with our planets. The neat elliptical orbits we know and love would be stretched and bent out of shape. The passing star would pull on everything, but the effect would be different for each planet depending on its position at the time of the flyby. It would be pure chaos. Jupiter, the giant of our solar system, might be tugged into a new, wider orbit. Mars could be pushed closer to us, and the asteroid belt could be scattered like dust in the wind. For Earth, the consequences could be catastrophic. Our orbit is a finely tuned Goldilocks zone. Not too hot, not too cold, but just right for liquid water and life. A gravitational nudge from a passing star could easily push us out of this comfortable zone. There are two main terrifying possibilities. The first is that Earth could be flung out of the solar system entirely. The star's gravity could act like a slingshot, accelerating our planet and sending it hurtling into the cold, dark emptiness of interstellar space. This would be a one-way ticket to a very lonely and frozen future. Without the sun's warmth, Earth would quickly become a rogue, frozen world. The temperature on the surface would plummet to hundreds of degrees below zero. The oceans would freeze solid from the top down, and the atmosphere would collapse into a thin layer of frozen gas on the surface. Life as we know it would be extinguished almost instantly. Our planet would become a dark, icy wanderer, drifting aimlessly through the galaxy for billions of years, a silent testament to a cosmic accident. It's a chilling thought, a world without a sunrise, forever lost in the dark. The other possibility is just as grim, but a lot hotter. Instead of being pushed away, Earth could be pulled inward, closer to the sun. The passing star's gravity could slow down our planet's orbital speed. When an orbiting object slows down, it falls closer to the body it's orbiting. Earth would be tugged into a new, tighter orbit that would spiral it toward our own star. Each day would get hotter and hotter as we move closer to the sun's blazing furnace. This path would lead to an equally certain but fiery end for our world, turning our blue marble into a scorched, molten rock. This might all sound like a wild fantasy, but we have evidence that a star has visited our solar system before. Don't worry, it happened long before any humans were writing things down. About 70,000 years ago, when early humans were sharing the planet with Neanderthals, a small, dim star known as Schultz's star made a close flyby. It was a binary system, meaning two stars orbiting each other, a small red dwarf and an even smaller, fainter brown dwarf. Together they drifted through the outer edges of our solar system, passing through the Oort cloud at a distance of about 0.8 light-years from our sun. Now 0.8 light-years might still sound like a huge distance, and it is. But in cosmic terms, that's like someone walking through your front yard. Schultz's star didn't get nearly close enough to pull Earth out of its orbit or cause any major planetary chaos. It was too small and too far away to have a significant gravitational effect on the inner solar system where we live. However, its passage was likely enough to gently nudge some of the icy comets in the Oort cloud, potentially sending a few of them on a long journey toward the inner solar system. These comets might have appeared in our skies thousands of years later. Scientists figured this out by studying the star's movement. By measuring its speed and direction today, they were able to rewind its path through space. Their calculations showed that its trajectory took it right through our neighborhood about 70,000 years ago. It's a fantastic piece of celestial detective work. This event serves as a real-world example that stellar flybys are not just theoretical. They can and do happen. It shows us that our solar system isn't an isolated island, but is part of a larger, dynamic, galactic environment where things sometimes get a little too close for comfort. A fun fact about Schultz's star: even at its closest point, it would have been too dim to see with the naked eye. It was a very faint red dwarf, so our early ancestors would have been completely unaware of the cosmic visitor passing by. They would have continued to gaze up at the same familiar stars, never knowing that another star system was making a historic, close approach. This real-life example reminds us that space is full of surprises, and there's always something new and amazing to discover about the universe and its history. So, should we be worried about a rogue star showing up and ruining our day? The short answer is no, not really. The chances of a star passing close enough to eject Earth from its orbit are extraordinarily low. Scientists estimate that such a catastrophic event might happen only once every few quadrillion years, which is far, far longer than the current age of the universe. While close passes like that of Schultz's star are more common, happening perhaps every few 100,000 years, they are still very unlikely to cause any direct harm to our planet's stable and life-giving orbit. But just because it's unlikely, doesn't mean scientists aren't looking. Astronomers around the world are our cosmic lifeguards, constantly scanning the skies. They use powerful telescopes on the ground and in space to map out the stars in our galactic neighborhood. Missions like the European Space Agency's Gaia spacecraft are creating an incredibly precise three-dimensional map of over 1 billion stars in the Milky Way. By tracking their positions, movements, and trajectories, scientists can predict which stars might be headed our way in the distant future. It's like having a cosmic early warning system. This ongoing effort is not just about looking for dangerous stars. It helps us understand the structure and evolution of our galaxy. By studying how stars move, we learn about the distribution of mass in the Milky Way, including the mysterious dark matter that we can't see directly. Every new piece of data helps us build a more complete picture of our place in the universe. We can calculate the future paths of nearby stars for millions of years to come, giving us plenty of notice if one ever looks like it might come a bit too close for comfort. So, you can sleep soundly tonight. The universe is a vast and sometimes chaotic place, but our little corner of it is remarkably stable. The Earth is not going to be kicked out of orbit anytime soon. Thanks to the tireless work of astronomers and the incredible power of science, we are watching the skies and learning more every day. Our planet has been on a steady journey around the sun for over 4 billion years, and all signs point to that journey continuing for a long, long time. The cosmos is full of wonders and surprises, and isn't it amazing that we get to be here to explore it?